Recording the meeting now. About to do that. The degree, the answer they want is in degrees. We've got 3/8 of a radian. So we have to convert that to degrees. How do we do that? Check in the chat. There's no answer. Well, it's those conversions are either pi over 180 or 180 over pi. We're converting to degrees, meaning the number is going to be big, right? You always have more degrees than you have radians, right? When you have, say, pi radians, that's 180 degrees. So the number is always bigger. So we're going to multiply by the bigger number, which is 180 over pi. So you can reduce the fraction or just go to the calculator with 540 over 8 pi. 540 over 8 pi. You can see I've done this before, but 540 divided by 8 pi, 8 pi. And it's 21.4859 degrees. They want what kind of accuracy do they want? Okay, so they're not really saying. So I would use that much accuracy that I just said. 21.4859 is quite accurate. Four eight five nine. 21.4859. Oh, they've got everything there, but so the rule then is more rather than less. If they don't make it clear. And just a reminder that the only the scientific calculator, not a graphing calculator, is allowed on this exam. Without using a calculator, compute the sine and cosine of 240 degrees by using the reference angle. Square root 2 for square root of 2 and square root of 3 for square root of 3. Square root of 3, yeah. What is the reference angle in degrees? Do it here. 240 is this angle here. So this big angle here, that's your 240. And the reference angle then is the positive angle made with the x-axis, which is this angle here, which is a 60-degree angle. Okay, 240 minus 180. So it's a 60-degree angle. I guess their annotations pen is kind of useful anyway. So it's actually not that bad. Instructions. I hope you people like read these about where it says more about the kind of answer they want. Enter your answer as an integer or decimal number. Okay, didn't give us a lot more. Reference angle here is just 60 degrees, so not a big issue there. I didn't see that in the other one because they didn't click in the box either. Now it's in that reference angle's in the third quadrant. The sine of 240. Sine is the distance above the x-axis, which at 240 is negative square root of 3 over 2. Okay, I'll use your pen. Negative square root of 3 over 2. Yeah, see how terrible that is? Now they put it in a decimal. Did they say to do that? So if I put negative square root of 3 over 2 in there, let this person in. I think they should allow it. Okay, so they say squirt 3 for square root of 3. So let's see. Negative squirt 3. Get out of the radical. Divided by 2. Good to me. Now there's something about all this that oh, I didn't do the last one. So they're saying that you got that wrong. So I didn't. Cos of negative 240. Looking for some kind of like indication that y'all aren't just bots. And welcome to the Mustafa bot. Negative 1/2. Cos is the distance to the left of the y-axis, which is negative 1/2. It says right there, for 240. And now you're like, if theta equals 5 pi over 4, both negative square root of 2 over 2. Builder. So number 11, even though it's like a skill that, but why don't y'all do number 11 there? Even though it's a skill that, we assume now, we're in chapter 8 now, we're kind of assuming you can do this because we rely on your ability to do this in order to do now the new problems. It's kind of a good problem. Find an angle theta between 0 and 360 that has the same sine as 250 degrees and the same cosine as a 250-degree angle. So everyone try that. Okay, so we'll see how we did here. Here's a 250-degree angle. It's kind of near that 240 that we were just looking at. 250 degrees. And the reference angle is that one. We are in the third quadrant where everything's negative. So reference angle (250 minus 180) equals 70 degrees. Now we're going to need the measure of that angle, and then we will use the fact that we're in the third quadrant and everything's negative there with this number to answer these questions. So if you ask the calculator for the sine inverse, right? Sine inverse is the angle such that the sine is whatever. Then, oh, well, we could just ask for sine of 70 degrees straightforwardly. Sine 70 degrees. Sine 70 degrees. Looks like I'm in degree mode. Not used to using this calculator. And cos Hypate, is it the same thing? It's just that's cos 70. All right, so 0.342 and 0.94 for the reference angle. So this point here at 250 degrees is 0.94 approximately, 0.342. And we want another angle that has the same sign as the 250-degree angle, the same distance above the x-axis. Well, that's going to be this angle over here. That's also going to be a 0.94. Um, what what is that angle? Well, it's a 70-degree angle. A negative 70-degree angle, negative 70. Now, that's not an acceptable answer. Okay, so this right here is negative 70 degrees. So how do we make our answer acceptable? We need an angle coterminal with that angle. Add 360. (360 minus 70 degrees sine of 290). So an angle in 0 to 360 that has the same sign as a 250-degree angle is a 290-degree angle. Cosine, same cosine as that. That's going to be an angle up here. With reference angle 70 degrees, this angle is going to be 180 minus 70. Which is 110 degrees. Okay, so question 12, we just did that, didn't we? Angle of 70 degrees, and we said that was 0.94 and 0.342. Oh, circle of radius 20. Okay, so this is kind of convenient because we just did this. So on the unit circle, the circle of radius 1, we found that for 70 degrees, the point on the unit circle was it was approximately 0.342, 0.94. What happens when your circle dilates and becomes a circle of radius 20? Well, we just multiply these numbers by 20. So for the same 70-degree angle, we're just going to 20x both of those numbers. $20x to get this number. And 20x to get this number. And yeah, that is going to be let's see. Multiply by 10 and double, so 6.84. And 18.8. So on a circle of radius 20, let's see, did they ask for the coordinates of the point or the sine and cosine? Same thing. Coordinates of a point. So that number and the 18.8. Okay, so values of the trig function for theta equals 13 pi over 6. So take 3 seconds and think about how you would do that. Okay, so secant theta. Secant 13 pi over 6. Well, that's more than 2 pi. If you subtract 2 pi from that, which is 12 pi over 6, you would have 1 pi over 6. Secant pi over 6. Now, of course, that is 1 over the cosine. cos pi over 6. Cosine of pi over 6 is square root of 3 over 2. So flip it, and you have 2 over square root of 3. And then we're going to rationalize the denominator. You know those graders for your final are going to be more interested in that than I would be. I would be happy with an answer of 2 over square root of 3. It's the correct number, but they say exact values. So we don't want a decimal, right? It has to be exact. And just to make sure, you know, we're okay, everyone's okay, everyone who might be grading this, you know, who might have a issue with having an irrational denominator like the square root of 2, we'll write this as 2 root 3 over 3. Any question? Okay, now the next one goes the same way, except that it's cosecant, so it's going to be 1 over sine. Then they ask for tan and cotangent. So it's kind of like it's interesting. So let's go ahead and do the cosecant one and see how we would use the results of that and what we just did to do one of those tan, cotan. For the reciprocal, and you'll have the other one. So cosecant 13 pi over 6. Let's do this. Oh. Okay. Cosecant 13 pi over 6 is the same as cosecant. Subtract 2 pi. That's a pi there. So pi over 6, which is 1 over pi over 6. Or I'm sorry, 1 over, and 1 over the sine of pi over 6. Which is 1 over 1/2, which is 2. And then we can put these together. Let's do the cotangent one. Now, cotangent is the reciprocal of tangent. So it's the reciprocal of sine over cos. So it's cos over sine. And yeah, let's do that. Tangent 13 pi over 6 is equal to the cotangent of pi over 6. Now, I was thinking about using these numbers to do that, but I think it's just easier and simpler just to say x over y, right? Cotangent of any angle is at just x over y. And on the unit circle at pi over 6, x is square root of 3 over 2, and y is 1/2. Square root of 3 over 2, y is 1/2. Right? The tan is y over x. And that's the one we really, you know, we just know that or memorize it or know it. And cotangent equals x over y. You know, that we'll take a moment to think that through to make sure we've got that. Well, simplifying, I'm going to do this canceling move, hack, hack, which is the same thing as flip the bottom and multiply and hack, hack. So this is just square root of 3. Any question about that? So good to remember this stuff. Now that we're getting into identities here, these are just fundamental identities. And I'm happy to talk about any of these. So speak up, say something in the chat, or just say something using your audio and stop me because I'm about to pass this over because obviously in chapter 7, we're going to have a lot of identities. Which will include the fundamental identities that we would use here. SOHCAHTOA, angle of elevation. Maybe I'll just draw that picture. And then not, go any further than that. Angle of elevation to the top of a building in New York is found to be 10 degrees from the ground at a distance of 1 mile from the base of the building. Using this information, find the height of the building. So just so you remember, my purpose is just so you remember what angle of elevation is. Of course, we're now in chapter 8 where we are, we're going to have a lot more problems involving angle of elevation and angle of depression. But angle of elevation is if your eyeball is on the ground, building, the door. Your eyeball's on the ground and you're looking at the top of the building, that's 10 degrees. That's angle of elevation. One mile. SOHCAHTOA. Now, maybe before break, we'll take a look, at least peek at the part 2 of the quiz 5, because now with law of sines, law of cosines, to me, these all fell in with learning target 5. Define, use, apply, and determine properties of trigonometric functions. Well, that's law of sines and law of cosines. That's using properties of trig functions. So I've got that in learning target 5. And so I put in a practice for quiz 5 part 2. Now, law of cosines, that is Monday. That's what we're studying on Monday. And some of these are law of cosines problems. And some of them are law of sines problems. How do we know which is which? Now, we talked about this on Monday, that for the law of sines, you could use the law of sines for law of sines. You could use it for an AAS, for an SSA, that's the ambiguous case, an ASA, that was law of sines. Law of cosines, which we're going to learn on Monday. We're going to learn that can deal with the SAS and with the SSS. So, in order to know which one to use, you will figure out if the known information, what the configuration is of the known information in your triangle. So let's see. It's first one, so maybe this is a law of sines problem. So let's see, 274-foot tower is located on the side of a mountain. that is inclined 24 degrees to the horizontal. A guy wire is to be attached to the top of the tower and anchored at a point 71 feet downhill from the base of the tower. Find the shortest length of the wire needed. Okay, so it's an oblique triangle. It is not it's not a right triangle. It's an oblique triangle, and so it's definitely a law of sines or law of cosines formation. Okay, we've got length of a side that's known, and that's 274. Okay, so we've got this side length for the triangle. And we have this one, 71 feet downhill. Okay, we're trying to get this. And what about angle? Now, that's 24. If we drop a perpendicular, we would have a right angle here. This is a right angle. This is 180 minus, well, it's 90 minus 24, so 66. Complement of that, yeah, by alternate interior angles, we know this angle right in there. Come on, eraser. Let's do some erasing. So that's 66. This is also going to be 24 right here because it's the complement. Together it makes a right angle. Right, together you got a right angle just like that. So that's 24. Now, that means the entire angle in our triangle of interest is 90 plus 24, which is for this one here, 114 degrees. And it looks like that. It looks obtuse, looks like 124 degrees, kind of getting into this disappearing ink thing. So let's mark that as a 114 degree angle. And $114 degrees. And that leaves, well, 66 for the other two angles. So we've got a known, we've got an SAS. Okay, we've got SAS. Two sides are known and the included angle. Now, this is not a law of sines problem, because for the law of sines, you either have to have a known angle and a known the side length of the side opposite that known angle known, or you have to be able to get it. And the only way to get it is with law of sines in this case. So we don't have, or law of cosines. Law of cosines is the only way to do it. So we don't have that. And so we will need to use the law of cosines for this problem. Law of cosines. And we're going to, at least if my plan in my head unfolds the way I think it will, we're going to have an activity which is a drill on identifying whether your problem is a law of sines problem or a law of cosines problem. And so after the break, my plan is to do a law of sines problem because we know how to do that. 8.2, you might have covered it. You might have done the homework and seen all the videos and everything already. You might have done that. So you might be ready to do this problem. You know, you're encouraged to do it over break. It's kind of weird to take a break now for me because I've taught a lot of online classes since the beginning of COVID, and not used to breaking at a time like this, but that was in the plan. So we will take a break for 10 minutes, come back and talk about the law of sines at 10:14. Here's the law of sines problem from the Quiz 5 practices. Path of a satellite orbiting the Earth causes it to pass directly over two tracking stations A and B. So that's what a satellite looks like right there. 69 miles apart. When the satellite is on one side of the two stations, the angles of elevation at A. So we talked about angle of elevation before the break. At A and B are 87.2 degrees and 84.5 degrees respectively. How far is the satellite from station A? Okay, so we want to know this length right here. And let's see what we can learn about this triangle that we see here. We know angle right in here is going to be 180 minus 87.2. So 92.8. 92.8 looks like that, looks obtuse. And the angle right up here is going to be, right, 180 minus the 92.8 minus the 84.5. So 180 minus the 92.8, which we happen to know is 87.2, minus the 84.5. So it's a tiny angle of 2.7 degrees. 2.7. So yes, indeed, the picture is not drawn to scale. So big note there. 2.7. So we have the lengths of all three sides, and we have one side length. And so we'll use law of sines. We're trying to get the length of this aqua colored side. And we'll call that length x. And so then by the law of sines, x over the sine x over the sine of 69 degrees, or x over the sine of, I'm sorry, 84.5 degrees. Is equal to 69 over the sine of 2.7 degrees. Multiply both sides by sine of 84.5. And we'll go to the calculator to get 69 times the sine of 84.5 divided by the sine of 2.7. Got the decimal point in the wrong place. 2.7. $84.5, 2.7, 84. 69 times sine 84.5 divided by, we'll have to ask ourselves whether that's a reasonable answer also, once we get this answer, which, well, don't want to prejudge. Sine 2.7 so we're getting 1,458 1,458 So x approximately 1,458. Now I know they want the units on the final. The person grading it, the units are going to be important. It might even be important to answer the word problem in words in a complete sentence. It's a word problem, so we should be doing this anyway. So let's see. Now that number looks right. It's believable in the context, so we believe that's correct. X is approximately equal to 1,458, and I think the units are feet. Oh, miles. So the satellite is about 1,458 miles from Station A. How high is the station above the ground? Well, how do y'all want to do this problem? Well, we have lots of options. Now we know X, we know that's 1458, so that's known. Just mark it like that. 1458. Call this Y. Y is what we're trying to get. We can get this angle here, which is 87.2. This 87.2 right here refers to this angle. And this one up here is also known then to be 2.8. Yeah, because you got the 90, you got the 87.2, so 2.8, which is too close to 2.7 for comfort, but that's what it is, 2.8. So we know the measures of all three angles. We don't know the length of the side on the bottom, but we do know the length of the hypotenuse of this right triangle. So it's a right triangle. So actually we could SOHCAHTOA it to get Y. So you could do that. Or you could just say, for example, that the tangent of 87 degrees, 87.2 degrees, which is opposite. Well, actually, we would just use sine, wouldn't we? Sine 87.2 degrees is y over the 1,458. So that one, once you do the first problem, and you'd probably want to keep a lot of accuracy. So I think it's worth, because of the final, for me, 1458 is close enough. But because of the way the final is likely to be graded by someone else, um, we will keep all of the accuracy that we can, because we don't want to be off because we rounded too much. 0.024042. Point 0.024042. Okay, and then you can finish that. Okay, let's go to quiz 6. Oh, maybe I'll check my question form, see if anything. Yeah, no one did that. That was supposed to drive this whole thing. Practice for quiz 6. Trig equation. Oh, this is good. Oh, this is good. Okay. Amplitude. Well, it's just that 2 that's right there. Period. So period is 2 pi over b for a sine, right? If it were a tan, it would just be pi. But for a sine or a cos or a secant or a cosecant, it's 2 pi over b. Now the b is the 11 pi over 6. Two pi over 11 pi over 6. Which is flip the bottom and multiply 2 pi times 6 over 11 pi. Go to Hacken. 12 over 11. Horizontal shift. Now, hopefully you were in class when we did these, and there was a lot of confusion about it. Horizontal shift is C over B. C over B. The C is negative 11 pi. Well, it's 11 pi. 11 pi. And the B is 11 pi over 6. So coincidentally, 11 pi appears in both the B and the C. So flip the bottom and multiply 11 pi times 6 divided by 11 pi. So it's just 6. Okay, so there's a horizontal shift of the graph of 6. You know, we can kind of see all this better if we write it as 2 sine, and then factor. Actually, it's kind of made for the factoring. Oftentimes that factoring is messy, but in this case, it's not. Well, it's kind of messy. 11 pi over 6 x minus 6. And then there's a plus 3 out here. Where, you know, if you were going to go back and do this distribution, you would have the 11 pi over 6x, which is the B. And then this one is the 6's would cancel, and it would just be 11 pi for the C. Last question is midline. So midline, like if you were, you know, picture this wave, then what would be the line that cuts through all of it? Now I would go to Desmos and graph it. You can, you know, hopefully you can imagine the wave, which starts at the origin, and then you get that wave going. And here there's a vertical shift of 3. And so the midline rises 3 also. And so the midline is the line y equals 3. Any question about that? Usually in an unshifted sinusoidal, the midline is y equals 0. In other words, the x-axis. But in this case, it is the line y equals 3. A horizontal line 3 units above the x-axis. Take a peek at the rest of Quiz 6 prep. That was good. Look at that again. See here, the midline looks like it's y equals negative 3. Okay, so we know that this one here is the reciprocal of sine, because that sine, you know, like I said, it comes in at the origin, starts at the origin, and then it does this, it does this wave. Pi, that 10 is terrible. But I do like, I find the disappearing ink useful. So that's 1 over sine, which would be cosecant. So cosecant x, cosecant. This one is tan. The one that goes through the origin is tan. Its reciprocal, which kind of looks similar, is cotangent. It's the one that has a vertical asymptote at the y-axis. That's cotangent. Again, talk about in our quiz 7 cram, for which there's not much time. So I think we're just going to go right there, unless I see something, which is a red flag. You would definitely want to plot all these points and excuse me, plot all these points and look at them and see what it looks like. I have to edit those because it might require modeling, which is impossible for our calculator. Inverse trig functions, evaluate the following. Do that bottom one there. And then maybe one trig identity problem. This one should be quick. Tan of the cosine of square root of 2 over 2. Cos inverse of square root of 2 over 2. Now, cos inverse of square root of 2 over 2 is the angle such that the cosine is square root of 2 over 2. The angle such that the cosine is square root of 2 over 2 is pi over 4. So all we have to do is find the tan of pi over 4. Well, this is y over x, sine over cos, if you prefer, where the cos we know is square root of 2 over 2. The tan is also square root of 2 over 2. So this is just 1. And we can see both of those on the unit circle right here. At pi over 4, they're both square root of 2 over 2. Next up, we'll do a problem in the quiz 7 practice. Rewrite that thing in terms of sine and cos. So cofunction identity there. You would take that argument x plus pi over 3. Well, actually, you'd probably use a double angle formula. And since that's actually the most important double angle formula of all, might be good to do this one. The addition formula for cos. So we have cos alpha plus beta is cos alpha, cos beta, minus sine alpha, sine beta. Right, so yeah. Addition formula for cos. Addition formula for cos down there, right here, is the one we're using. And I say it's the most important because the rest of them are derivable from it. Using, well, if you wanted a subtraction formula for cos, you would just replace beta with negative beta, and then use the even odd identity, the fact that cosine is an even function and absorbs the negative, and the sine is an odd function and the negative comes out through, becomes a multiplier of -1. Anyway, for this problem, cos x plus pi over 3 equals cos x cos pi over 3 minus sine x sine pi over 3, which is cos x times 1/2 minus sine x square root of 3 over 2. So you can make it, now we've written it in terms of sine and cos. So kind of a weird problem because it's already in terms of just cos. Oh, I guess they want you to throw in that sine there. So we've done that. 1/2 cos x minus square root of 3 over 2 sine x. All right. So call it a day. And thanks for coming in. Thanks for coming in, and feel free to contact me about any of these things or anything else you see in these practices. This exam, of course, is a week from today. On Monday, we do law of cosines, and then on Wednesday, we've got the exam 3. And then Friday, the final exam cram, and the final. So have an awesome break, and see you Monday. Yes, you too.